Hey guys, hello. So today we are going to solve this question which appeared in GIT 2020. The question says we have to choose a function among these four which is not analytic at all the points. Please focus on the word all the points of the complex plane. So if this is complex plane, then the function f of z should not be analytic at all the points for all z belongs to complex number. Okay, this f of z should not be analytic. So this is the question. Let's clean this thing. Okay, now start with option A. So first option is f of z equal to z square. Okay, so before going into the solution, first we have to check what is the definition of analytic function. Okay, what is an analytic function? So if we define f of z equal to u xy plus iota vxy, okay, then this function f of z will be analytic if now we have to follow the Koshi-Riemann theorem. Okay, the shear theorem we have to follow, and which says that u of x equal to v of y, the partial derivative of u with respect to x should be equal to partial derivative of v with respect to y. If this is same, and u of y equal to minus v of x, if the function f satisfies these two conditions, then we can say that the function is analytic function. Okay, now to check the option, we have to check this condition, these two conditions for all the options. Okay, let's start with option A. So for option A, f of z equal to z square, which is x plus iota y square. This will be equal to x square minus y square plus 2 iota xy. This is our u, and if I write iota before 2, then this 2xy thing, let me highlight it, this 2xy thing is v, and this x square minus y square is u. Now check these, first check this condition. So partial derivative of u with respect to x is how much? It's 2x, and check whether this is equal to partial derivative of v with respect to y. So this will be again 2x, partial derivative of v with respect to y. So first condition is satisfied. Now check for second. The uy is minus 2y, this is minus, the partial derivative of v with respect to x is 2y. This also satisfies. So for option A, both the condition of Cauchy-Riemann theorem satisfies, so this is analytic function. Okay, similarly we will check for option B. Let's clear this thing before we check for option B. Okay, option B is E of z. So we can simply write E of z as Ex plus iota y, which is Ex times e power iota y. Okay, from iota theta e power iota theta equal to cos theta plus iota sin theta. So we will expand this term using this formula. So we get cos y plus iota sin y. Okay, now multiply ex with inside. Okay, so ex, so this will be this become ex cos y plus iota ex sin y. Okay, let me change the color of the pen. Now this is u, this is v. So first check this condition. So take partial derivative of u with respect to x, that will be, so take partial derivative of x, partial derivative of u with respect to x, so it will be ex cos y, take partial derivative of v with respect to y, so it become ex derivative of sin y equal to cos y. So first condition satisfied, this condition satisfied. Now check for second. So u of y is equal to ex sin y with minus, this minus here, partial derivative of v with respect to x becomes e power x sin y. Again, in this option also the Koshi-Riemann equation, the Koshi-Riemann theorem is satisfied. So our option B is also analytic function. Okay, now we have to check for third option, which is f of z equal to what? Sin z. Okay, write it again. U of x equal to plus v of y. The third option is sin z. So this becomes sin of x plus iota y. Now use sin a plus b formula to expand this term. This becomes sin x cos iota y plus cos x sin iota y. Okay, now here iota is inside the sine function. We must convert this thing into this form, means this should be function of x and y, no iota inside u. Similarly, there is no iota inside v function, so we have to convert this form into this form. So to convert into that form, we must know that cos iota y is cos of hyperbolic y. This both terms are same. Similarly, sin iota y is equivalent to iota sin hyperbolic y. These two formula these two terms you should remember. This may come handy into the exam. Okay, so okay, let me clean something for you. This So now we can okay, so I'm writing here, so this sine z becomes sine x cos hyperbolic y plus iota cos x sine hyperbolic y. Now okay, this is u and this is v. Now apply Koshi equation again. Okay, so what is ux? This, so this becomes cos x cos hyperbolic y. This must be equal to v of y. So take derivative of this term with respect to y. So this is cos x and the sign becomes cos hyperbolic y. These two terms are same. Similarly, we have to check this term also. Okay, so take partial derivative of u with respect to y. So what is this? This becomes sine x and this is sine hyperbolic y. So you must remember this thing that when we take partial derivative of cos x, then that becomes minus sine x. But in case of hyperbolic function, there is no negative, means cos hyperbolic y simply becomes sine hyperbolic y. Now this is minus sine and take partial derivative of v with respect to x. Take this, so this cos x becomes minus sine x, so this is positive sine x and sine hyperbolic y. Okay, so this is the term, and we somehow got that both the conditions of Cauchy-Riemann theorem are satisfied. For this c function also. So this is also an analytic function. Now check. Now the only left option is D. So D must be the answer, and D should be should not be an analytic function. Okay. So whether we will check it. Let's check it. We can simply check it with the Cauchy-Riemann theorem. We have to follow the same procedure that I followed for option A, B and C. Okay, so what is this? This is cos log z, so log z becomes okay, so z is so we know that z can be written as mod z e power iota theta. Okay, so write mod of z e power iota theta, and theta, where theta equal to tan inverse y by x. So we should know these two functions, these two formula to solve this f of z. So this becomes log of mod z, which basically is log of x square plus y square power 1 by 2 plus iota theta. Theta is tan inverse y by x. Okay, so now this term is u, and the term beside the iota is v term. Now we again check for the Cauchy-Riemann theorem.